In this video, we want to use circle geometry to find the angle sizes of the following 8 angles. We are given that the line AC is a tangent to the circle and O is the center of the circle. We are also given that BD is equal to DE. So it's not shown on the diagram. So let's fill in that information. So we have BD is equal to the line DE. Next, we have that the angle of B1 is 40 degrees. So let's put in B1 as 40 degrees. So our first question is find the angle size of E1. So we can see that E1 is an angle at the circumference of the circle and it's connected to the chord of DB. And we know that the angle between the chord and the tangent is equal to the angle formed at the circumference. So therefore, E1 is 40 degrees, tan chord theorem. Next, we want to find angle B2, and we can see that B2 forms part of this triangle, and we also have that DB is equal to DE. So that means that it is an isosceles triangle, which will make B2 equals to 40 degrees, angles opposite equal sides. Next, we want to find the angle size of D. So we can see that D is also part of the triangle DBE. And we can use sum of angles in the triangle to find D. And that will be 180 minus 40 minus 40, which is 100 degrees. So D would be 100. Our next question is to find the angle size of F. So we can see that F is part of the points on the circumference of the circle, and that forms a cyclic quadrilateral. And what we know is that the opposite sides of a cyclic quadrilateral are supplementary, meaning they would add up to 180 degrees. So therefore F is 80 degrees. Next we have EOB, so angle EOB. It's safe to assume that it's the obtuse angle, and we know that if O is the center of the circle, that the angle at the center is twice the angle at the circumference. So EOB would be equal to 160 degrees. And if you want to find the other angle, that will be 200 degrees because angles around the point add up to 360 degrees. Next, we want to find the angle E2. Now, E2 is in the triangle EBO. And we know that OE is a radius and OB is a radius. So therefore, these two sides of the triangle are equal, meaning that E2 would be equal to B3. And then we can use angles within a triangle to solve E2 and B3, which is both 10 degrees. Next, we want to find OBC. So the line from O to B to C. That's the angle formed between the radius of the circle and the tangent of the circle. And we know that the tangent is perpendicular to its radius. So that angle would be 90 degrees. And lastly, we have angle EBC. So angle EBC. So we have B3 is 10 degrees and the angle OBC is 90. So EBC together would be 90 plus 10, which is 100 degrees. You can also notice that that angle is connected to the chord. And we know that the angle between the tangent and the chord is equal to the angle at the circumference. So the angle EBC would be equal to the angle of D, tan chord theorem. So now that we have solved all of these values, let's quickly write down the proper reasons. So first we wanted to find E1, and we said E1 is 40 degrees, tan chord theorem. Next we said B2, and B2 is also equal to 40 degrees, and the reason is angles opposite equal sides. So we don't say isosceles triangle, we say these are angles opposite equal sides. We said D1 is 100 degrees, and our reason was the sum of angles in the triangle. Then angle F is equal to 180 degrees, and our reason is opposite angles of a cyclic quad. Then for angle EOB, we said that is 160 degrees, and the reason we used is angle at the center equals 2 times the angle formed at the circumference. For angle E2, we need to make a separate statement, so we can say OE is equal to OB because these are both radii. Therefore, E2 is equal to B3, and our reason again is angles opposite equal sides. Therefore, E2 is equal to 10 degrees, and this is sum of angles in a triangle. Next, we said OBC is 90 degrees, and our reason is the tangent is perpendicular to the radius. And lastly, the triangle EBC is 100 degrees, and I would say that's the tan chord theorem.